you see when I move it back, the 2 is going to swing around to the right, the 3 is going to go to the back and then end up on the left. So I do that, and you see now the red came over here to the right, and the 2 is now on the left. If you're having trouble seeing how this worked, build yourself a model. Put 4 different color carbons, and then assign them priority, 1, 2, 3, 4. If you want to put little stickers on them so that you remember what is the priority of them. And then take that lowest priority one and rotate it back behind the carbon so you can't see it, or that it's somewhat obscured, but directly behind it. Now what we do is we look at the priorities of the groups that are around the carbon facing you. If I look, this is the highest priority group, that's the second highest one, and that's the third highest. The order of priority is going clockwise. Because it's going clockwise, we call it the R enantiomer. So this has R configuration. Now we're going to go through how to assign the priority. The highest priority is given to the highest atomic number atom. So what you do is you examine the first atom in the group and prioritize based on that. If you find that 2 first atoms are the same, then you advance to the next atoms. There are usually 3 atoms, there can be 3 atoms attached if it's like a carbon, or if it's an oxygen, there's only going to be 1 group attached. If there's a nitrogen, there's going to be 2 groups attached. So what you have to do is look at the first atom and get those priorities set up. Then you look at the next atom if you find any 2 are the same. Where it gets confusing is double bonds. If I look at double bonds and triple bonds, for instance, down here, this carbon is double bonded to the oxygen. That means basically we give it the priority as if it's 2 oxygens attached. But you have to realize that the oxygen is bound back to the carbon. So we give one of the oxygens a priority as being attached to a carbon. Okay? If I have a triple bond, it is like 3 nitrogens are attached. 1, 2, 3. And if I look, 2 of the nitrogens have another carbon attached. So I give it this kind of thought. Okay, I imagine after that last slide you're entirely confused. It's very confusing. The only way to understand this is to go through some examples very slowly to help you understand this little bit at a time. Okay, so let's look at the groups that are on this simple molecule. There are 4 different groups. This carboxyl group, here we have a methyl group, here we have a hydroxyl group, and here we have a hydrogen. Let's assign priorities to them. This carbon is now chiral because of the 4 different groups. So if I look at carbon, carbon, oxygen, hydrogen, hydrogen has the lowest mass, so it's the lowest priority. So the first thing I'm going to do is I'm going to rotate it to the back. So here is the structure now with the hydrogen rotated to the back so it's behind the carbon. What's left is this group, and this group. So now we compare oxygen, carbon, carbon. Oxygen has the greatest mass, so this is going to be my number 1 priority group. Next, I look at carbon and carbon, they're the same. So I move on to the next atoms. Oxygen and oxygen and oxygen, they're actually a priority of 3 oxygens bound to this carbon because one of these is double bonded. And then on this carbon, you have 3 hydrogens. Oxygen outweighs hydrogen, so this is the next priority group. Number 1, number 2, number 3. So now that is the ranking of these groups. Now we look to see which direction does the priority go? Does it go clockwise or counterclockwise? If I look 1, 2, 3, that's clockwise, so we assign this the R enantiomer. So in front of the name of this compound, I would write an R. Let's look at its enantiomer. If you look, this is a mirror image of this one. See, the methyls are the same, the hydroxyl the same, the hydrogen, and the carboxy group, all the same. It's just a mirror image. So first thing we're going to do is rotate the hydrogen to the back because it's lowest priority. Now you can see that I've got this hydroxyl group, a methyl group, and the carboxy group. The highest priority is going to be 1, second is going to be this group 2, and third will be this group. So 1, 2, 3. Now let's look at the rotation of the priorities. 1, 2, 3. That's counterclockwise. So we give this the S designation. Notice enantiomers are opposite. One enantiomer is always going to be R, and the other enantiomer is always going to be S. If I want to compare two groups that are a little bit more similar, I always look at the groups of atoms that are attached and find the highest priority atoms. Let's look and see what I'm talking about. Right here is an ethyl, and here is a methyl. So if I draw them out, I've got this. I did that so it's easier to look at. So now let's look at the first atoms attached. Those are both carbon, so they're the same. Then I look at the next atoms attached. This one has hydrogen, carbon, hydrogen. So I list them, carbon and 2 hydrogens. This one has 3 hydrogens, 3 hydrogens. If I look at the top priority group, it outranks this top priority group. So which one has greater priority? This one. So if you list your atoms like this and look at the top ranking atom and compare the 2 top ranking atoms, you'll have an easier time determining priorities. Okay, so now we're going to look at dealing with double or triple bonds. When you look at a substituent that has a double bond in it, draw it out as if it is single bonds. How do you do that? This carbon is attached to 2 oxygens, so we draw 2 oxygens out. Then we recognize that the oxygen also is bound back to 1 carbon. So on one of the oxygens, we actually consider it to be bound back to 1 carbon. You don't really have to draw this. You can think it through. You might find it useful to draw it out. If I go and look at this one, it's all single bonds, so it's really easy to look at it and figure it out. So now let's go ahead and look at the priorities of the atoms. These 2 carbons, they are the same. So we have to look at the next atoms. What's attached? Here it's an oxygen, and a carbon. So I list oxygen, oxygen, carbon. If I look down here, this carbon has oxygen, hydrogen, hydrogen. So I list oxygen, hydrogen, hydrogen. Now I go and I compare. As I go down the list, oxygen, oxygen the same. Then oxygen, hydrogen, well, that oxygen outweighs that hydrogen, so now I know this group has higher priority. Now what I want you to do is try this all on your own. Go ahead and order the priority. The priority that we've been looking at is called the Cahn-Ingold-Prelog system. So go ahead and order the priority of these according to what we have been doing. Assign 1 highest priority to 4 lowest priority. Okay, let's go ahead and look at them individually. This carbon has chlorine, hydrogen, hydrogen. This carbon has oxygen, oxygen, hydrogen. This carbon has carbon, 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 and this carbon has nitrogen, hydrogen, hydrogen. Well, the one with the chlorine attached has the greatest mass, so this is going to be my number 1. If I look at next, I would see oxygen versus carbon versus nitrogen. Oxygen outweighs both carbon and nitrogen, so this is number 2. Then I look at carbon versus nitrogen. Nitrogen outweighs carbon, so this one's next. So this is 1, that is 2, this is 3, and let's go through a few examples of how you determine priority. Let's look at this aldehyde group as compared to this methyl hydroxy group. The aldehyde group has higher priority than the methyl hydroxy group because this is oxygen, oxygen, hydrogen attached there. So oxygen, oxygen, hydrogen. Here we have oxygen, hydrogen, hydrogen. So the second oxygen here is higher priority than that first hydrogen, so this group has priority. Even if I have this aldehyde group and I compare it to this methyl peroxyalcohol group right here, let's go ahead and see. This is going to be oxygen, oxygen, hydrogen. What's attached here? It's going to be oxygen. You see this oxygen is attached to that oxygen. So it's oxygen, hydrogen, hydrogen. So it's still, this oxygen outweighs that oxygen, so this has priority. If I look at this ethylene group and compare it to this diethyl methyl group, let's look and see which one has priority. Here, what's attached to this carbon? 2 carbons and a hydrogen, so it's carbon, carbon, hydrogen. If I look at this group, what do I have? I have 2 carbons and a hydrogen. So I can't look at the first line, okay? I have to go to the next. What's attached to this carbon? Well, there's a carbon back and then 2 hydrogens. So carbon, hydrogen, hydrogen. What's attached to one of these carbons? One of these carbons. It's carbon, hydrogen, hydrogen. So because it is carbon, carbon, hydrogen, this second carbon outweighs that hydrogen, so this group if I look priority. At these, I will see the atoms to consider for priority. Let's look. Carbon, carbon, hydrogen. This is carbon, carbon, carbon. This has greater priority than this one because this one's carbon, carbon, then hydrogen, carbon, carbon, hydrogen, and then carbon, 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 so higher priority. Let's look at this one compared to this. If I look at this carbon, what's attached? Carbon, carbon, hydrogen. What's attached here? Carbon, hydrogen, hydrogen. That one has greater priority. Let's look at this. This is carbon, carbon, hydrogen again. What's this going to be? Carbon, hydrogen, hydrogen. Higher priority here. Okay, what you've been learning so far is called the Kahn-Ingold-Prelog system, how to order by priority. What I want you to do now is take that system that you've learned and assign priorities to these groups. Okay, let's look at the groups that we have here. Of course, carbon is all the same, so we have to go to the next tier of atoms. So we see carbon, hydrogen, chlorine, hydrogen, hydrogen here. Here we see oxygen, oxygen, hydrogen. Here is carbon, 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 and here is nitrogen, hydrogen, hydrogen. If I look at which group has the highest mass second tier atoms, we'll see chlorine outweighs them all. So it has number 1 priority. Next, I look and I compare oxygen, hydrogen, hydrogen to carbon, hydrogen, carbon, 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 and nitrogen, hydrogen, hydrogen. Oxygen outweighs them all, so it's number 2. Then I compare carbon to nitrogen, hydrogen, hydrogen. Nitrogen outweighs carbon, so that's my number 3 priority group. And then last of all, we have the carbons. Here are some molecules that I want you to find in each molecule the chiral carbon, assign priorities, and then assign it as being either R, clockwise rotation, or S, counterclockwise rotation. In this molecule down here on the right, you need to find 2 chiral carbons and assign R or S stereochemistry to it. Okay, so let's start with this molecule up here. Assign priorities to each of the group and then determine whether it's R or S. Pause and then resume after you've figured it out. Okay, the first thing that we have to do is assign priorities to these groups. The number 1 priority group would be the bromine, number 2 would be the ethyl, and number 3 would be the methyl. Hydrogen will be the lowest priority group. In order to determine if it's R or S, we need to take the lowest priority group and put it to the back. So when I put it to the back, this ethyl will remain on top, the bromine is going to rotate over this way, and the methyl is going to move over here. So it will look like this. So now let's assign priorities. 1, 2, 3. If I look at this, this is the order of the priorities. Bromine number 1, ethyl number 2, and methyl number 3. So this is rotating in the clockwise direction, so this is the R enantiomer. Now go to this molecule and do the same thing. Okay, if we look at this molecule, the lowest priority group is the hydrogen, so it's going to be put to the back. Then we have ethyl, methyl, and this is called an ethylenyl group. When we rotate the hydrogen to the back, the methyl is going to come over around to this side, and this double bond group is going to move over here to the right. So this is what we get as a result. The number 1 priority group is this is called a vinyl group. Right here is the vinyl group. The number 2 priority group is ethyl, and number 3 is methyl. That means we're going counterclockwise, so it's an S enantiomer. If we go up here to this group, the hydrogen's already to the back here. So let's assign priorities to the groups. I've got methyl, which is lowest priority. I've got a carbon with a double bond on it, which is highest priority, and then this is the intermediate priority. So the group priority is the right side of the ring is highest, the left side is second, and then the methyl group is lowest. The direction goes like this, so it is rotating clockwise, and so it is the R enantiomer. If I go down to this molecule, you will find on this carbon, the hydrogen is already to the back. This is the highest priority group. This is the second highest priority group, and this would be the lowest group. So the direction 1, 2, 3 is counterclockwise. So this carbon is S. If I look at this carbon, the hydrogen is coming out at you. I'm going to show you the easy way to figure this out. The easy way to figure this out is to remember the hydrogen's coming out at you, and if you were to turn the molecule, if this group was instead coming forward and the hydrogen back, that would be the opposite of what it is now. So what we're going to do is we're going to assign priority on the groups through just the way that they are, and that realize we have to turn it or change the rotation, have the opposite rotation in order to figure out the chirality here. So what's the highest priority group? Well, if I look at this carbon has carbon-carbon hydrogen attached. What does this one have? carbon-carbon, and a hydrogen. Which has greater priority? Well, let's look and see what's attached to it. Attached to each of these, to this carbon are two carbons. One carbon is going to be carbon, hydrogen, hydrogen. If I look at this carbon, it's going to be hydrogen, 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 and we can see that's lower priority. But let's go to this one. This one's going to be carbon, hydrogen, hydrogen. Which one has greater priority? Well, we go one more. If we go one more, we have nothing over here. If we go one more here, we've got carbon with a carbon, hydrogen, hydrogen on it. So we can see this is going to be higher priority. So this is the number 1 priority group, this is the number 2 priority group, and then this would be the number 3 priority group. So we're going 1, 2, 3. And you would say for this, if the hydrogen were going back, that this would be counterclockwise. But the hydrogen is going forward. So it must be the opposite, clockwise. So it's R. So this one, S, because top is number 1, the bottom's number 2, and the methyl's number 3. So the rotation goes counterclockwise, S. For this carbon, the bottom side's number 1, the vinyl is number 2, and this part is number 3. So if I go and look at the rotation with the hydrogen coming out, I get counterclockwise. But because the hydrogen's coming out and needs to be going back, it must be R. Here's another one for you to try. Go ahead and do these 5 compounds. Assign them R or S. These might be a little bit easier because they're easier to see. So they're a good thing to try. Okay, so for the first one, I look and it's very easy because you just have single atoms. So I look, bromine's highest mass, iodine's highest mass, then bromine, then fluorine, and then hydrogen. So the hydrogen goes back, which is already shown going back. So my priorities are going to be iodine, bromine, fluorine, and then hydrogen. Let's look at the rotation. That's going this way, counterclockwise. So this is an S carbon. If I look at this one, what do I have? If I look at this one, 2 groups are the same. So it's achiral. Not every carbon is chiral and can be assigned R or S. Let's do this one next. Okay, if I go and assign priorities, highest priority, second, third, lowest is the hydrogen. In this one, you actually have to turn the molecule so the hydrogen goes to the back. That will put the methyl up, the bromine to the right, and the chlorine to the left. Rotation goes bromine, chlorine, methyl. So that would be counterclockwise, so it is S. Oh, excuse me, clockwise, so it is R. Okay. Then, if I look at this group, try this, and then restart the lecture. Okay, so if I assign priorities, this is going to be the lowest priority group. If I look, there are 3 nitrogens attached to this carbon. There's nitrogen and hydrogen, hydrogen, and then we have oxygen. Oxygen outweighs both of those carbons. So the highest priority group will be the alcohol group. Next, if I look, this is nitrogen, hydrogen, hydrogen on this carbon, and nitrogen, nitrogen, nitrogen. There's a triple bond in here. So this group has 3 nitrogens on it, and this has only 1 with 2 hydrogens. The second highest priority group will therefore be the nitrile, and then this will be the third. So if I turn this around so the hydrogen's going back, the hydroxyl will be on the left, the nitrile at the top, and the amino-methyl group will be on the right. That's going clockwise, so it is R. if I look at this group, I will see what's the lowest priority group? The hydrogen. Okay, so that's going to be pushed to the back. What's left in priority is this is carbon with an oxygen and a hydrogen attached. This is a carbon with 3 carbons attached. And this is a carbon that this is an acid group, so there's a double bond to an oxygen and then another oxygen on the OH. So this is carbon with 3 oxygens attached, carbon with 3 carbons attached, and a carbon with 2 hydrogens and an oxygen attached. The highest priority group is going to be this. Next will be this one. And then this one will be last because oxygen outweighs a carbon. That's why this one's higher priority. So let's go ahead and put this in 3 dimensions. The hydrogen back will put this acid group on the left. It will put this methyl hydroxy group on the right. And then this group will remain up. This is the highest priority group. So highest priority, then over here to the right for the methyl hydroxy, and then up to the top for this group. So what's the rotation counterclockwise? This is an S.